Welcome back, my students, from your Christmas break. It's Mr. Chang coming at you. So the way today's lesson is going to work is I have to do a video lesson with you. We have to do this asynchronously, even though we have a synchronous time slot for class today. And the reason is because there is a staff meeting scheduled in the afternoon, and any classes that are scheduled in the afternoon are going to be taught asynchronously because teachers are in a staff meeting. Okay, so um, welcome to Unit 3, Quadratics Part 2. Before we get to it, I just want everybody to have a look into their assignments folder or their grades. You would have received your test back already, so please, make sure you go and check that. The tests are returned. Yay. Okay. I actually did that, what would be yesterday night for you guys and girls. And I want to make a call out actually to some very special students. Their names are, well, first off, I want to name the students who got perfect or next to perfect. That's Matt Daly, perfect score. Also, Devonte, perfect score. And let me see if I'm not missing anybody else for perfect score. Like if you've been keeping up with this stuff and you've been doing your homework, you've been asking questions, hopefully you should be discovering that either you know all this stuff and you got lucky because you didn't make any silly mistakes, or you're really diligent in making sure you catch these, like Matt and Devonte, two perfect scores, right? Or maybe you just kind of skipped over something or didn't notice a detail and made a silly mistake here or there. And but you've had pretty good practice, and you would have ended up with a really high mark or a significant improvement. So these people are Mike, Madison, Mackenzie, Jordan, uh, Ariana, Connor, um, Sierra, Jared, and Batul. Congratulations on making significant improvements. For some of you, it's just simply a much better mark than you normally got. And that is, in my opinion, better than perfect. Because if you got perfect, you might be a student that's just getting perfect all the time. And you know what? They've already achieved everything that they need because their learning skills are on point, and it gives them great results. That's fantastic. It took a lot for them to get to where they are, but they're getting what they're expected. But for students that made a significant jump, you actually changed your learning habits. You changed your attitude towards maybe this unit, and you decided to work hard. Something happened and you were able to make a change. And when a dynamic change like that happens in somebody's life, and they're able to get a positive result, I just want to say congratulations on it. Okay, well deserved. Okay, let's get to this lesson. Today we're going to cover expanding binomials. That's the point of today's lesson on Monday, January the 4th. Okay, and we got practice on page 3 to 5. I'll try to make the lesson rather quick because a lot of it is just really just multiplying. And this is where we're at today, right? Tomorrow we got you know, online learning again, but it will be with me live chatting on Google with you. Okay, so let's talk about the first lesson here, expanding binomials. This outline's available for printing as well, and here's a workbook, right? So expanding binomials, this is a workbook. Hopefully you got it in front of you. This definitely should say Unit 3. I keep on forgetting to change that little detail. It used to be a Unit 5, but it makes more sense as a Unit 3. Okay, we got some quick terminology for you guys to copy down. I want to talk about what a polynomial is. It's an algebraic expression with terms that are added and subtracted. So maybe just write add and subtract terms. Okay, and when you're adding and subtracting unlike terms, that's probably better. Unlike terms, then each of those terms is considered one more part of your polynomial. Okay, so let's talk about the terms first, and I'll show you what this stuff looks like in action. A term is a product of a numerical coefficient and variables. A product of numerical coefficient, that's a number, right? And the variables. And of course, a product occurs when you're multiplying something, okay? And in the same case, you could argue that multiplying is dividing because, for instance, if I multiply 10 by 1 over 2, right, the fraction, that's the same as 10 divided by 2, right? So we're just loosely using the term product, which means things that are multiplied together or divided together, and there could be a number and a variable, like, for instance, 5a or 5a squared, right? A monomial is a polynomial with one term. This is two terms in a binomial. And a trinomial has three terms. Okay, think about monorail or monocycle or monocles. That's one glass for your eye as opposed to two. Like think about Mr. Peanut. Okay, that's he wears a monocle, or you can wear a binocle. Well, it's actually binoculars, right? Or you can say they're bifocals or two lenses, all right? Or trifocals, but nobody really needs that because nobody has three eyes that I know of, okay? Expanding, here we go. Review of expanding. When we're expanding, that's simply multiplying terms together, then add or subtract any like terms, you know. The end result is you're going to have a polynomial with no more like terms, and you can't do anything left. And the distributive property is multiplying to terms in brackets. Multiplying into brackets. Why don't we say into brackets? And let's show you some of this stuff in action. Okay. So here we go. It says simplify the following. It says 12x plus 3y minus 13x plus 5y. The printout obviously isn't the best, but we can make out what it actually says. And here we go. What you need to do is you need to look for like terms, right? Like you want to just go ahead and add and subtract all these things. And if it was like 12 plus 3 subtract 13 plus 5, you can definitely go ahead and do it. Why? Because they're all like terms. And a like term is a term or two terms that have the same number, variables with exponents. So here, like for instance, like 12 plus 13. These are the same numbers with same exponents. In fact, there's no exponents. So 12 plus 13, you can add it together. Okay, but 12a plus 13, no, these are not like terms. These individual terms separated by the plus sign are not the same because this is 12 times a, which is not the same as 13. Okay, but if this was 13a, I could put this together. I could get here, you know, on the top, I'd get 25, but over here, I'd get 26, 25, sorry, A. Okay, so in the same way here, you got to look for like terms, and we do have a like term here and here. These two are like terms because they have the x's, right? So let's just handle these two first. 12x subtract 13x is negative 1x. Then over on the next one, we have the positive 3y and the positive 5y, and they're both terms with a y, right? And so 3 plus 5 is 8, and so we go 8y. So you can write it as negative 1x plus 8y, or if you want to go a little bit shorthand on it, you can go negative x plus 8y. Both of these are great answers. All right. Okay. So if you do the same thing over here, you want to see if you can collect the like terms. However, they're wrapped up in brackets, and you're like, okay, well, what's going on with the brackets? You understand that according to BEDMAS, okay, you actually have to handle doing what's in the brackets first. Okay, so let's look at it. 3x plus 4y. What do you want me to do? You want me to add, right? You want me to add. But the thing is, I can't, right? I can't add 3x plus 4y. So in this particular case, I can't do anything. So all I'm going to do is just open the bracket. Okay? But if you look over here, 3x plus 4y needs to subtract 5x minus 6y in brackets. And again, if you look in the bracket, there's nothing going on. But I'd like to open it. So if I just open it, the problem is this negative on the outside needs to be applied to this and this. Okay? And so if you do that, this positive 5x should actually read as a negative 5x. And this negative 6y should actually read as a subtract a negative positive 6y. Okay? At this point, you can collect like terms. And looking at the x terms, I get 3x and negative 5x, and I get negative 2x. And over here, I've got a 4y and a 6y. And if you add those two together, you get a 10y. Okay? There's nothing left to do. These are unlike terms. Okay? This is negative 2x plus 10 times y. Negative 2 times x plus 10 times y. You can't turn that into 8y or 8xy. It doesn't get together. Okay? You got to know when to stop. Okay. So that's the distributive property. You're distributing over here with a negative going in, and also just collecting like terms. This is multiplying binomials. If I put two binomials together, a plus b, okay, and c plus d, and I multiply them, you can see there's no operation in between here, these two brackets. That actually means you're multiplying. Then what you have to do is you have to multiply this first term by both this and this. A has to multiply to C and has to multiply to D. And if you look at the B here, it needs to multiply to C and it also needs to multiply to D. So there are 1, 2, 3, 4 interactions that need to happen. So when A multiplies to C, I have one interaction. I also have A multiplied to D, or A multiplied to, what did you say, A times D? Yeah, this was written wrong. I'm sorry. This should say A times D. Okay, so A times D also occurs. That's A times D. Okay, and then you also have, let me see if I can make a quick correction. I don't like that. That is ugly. A times D, please. Okay, you have B times C. There's A times D. You have B times C, and you also have B times D, which is right there. So you end up with these 4 interactions, separated by what looks to be adding because these are all positives, so that's the result. Okay? We call it FOIL because you have to multiply the first terms, that is the first terms here. Then we have to multiply the outside terms. Okay, the outside terms are this one and this one. Then we have to multiply the inside terms, and the inside terms are this one and this one. And then we have to multiply the last terms, which are this one and this one. And all these interactions happen like that. So I'll do maybe a couple examples, and I'll let you guys carry on with the rest of these. Okay? Here's x plus 2 times x plus 4. What does this mean? Well, x times x gives you x squared. X, right? X times x is x squared. Then you have to go x times a positive 4 there to get positive 4x. We have 2 times x, which is the insides now, which is positive 2x. Then we have to multiply the last terms here according to FOIL, right? 2 times 4, which is positive 8. There's no x, right? These are just the numbers 2 and 4 multiplied together. If you look inside here, you want to look for like terms. Do we have any like terms that need to add and subtract? X squared doesn't have anything that's on its same, but if you look at the 4x and the 2x, these are like terms, so you can actually add these together. So I can rewrite everything else, but 4x plus 2x gives me 6x. I also have the 8, and I'm done. Okay, I'll let you guys go ahead and carry on and do 2, 3, and 4. You can stop it. And tomorrow when I see you again, we'll definitely take this up. But try your hand at working out 2, 3, and 4. Okay. Then what about over here, right? You have to state an expression for each area, for the area of the shape given below. Yeah. And I'm going to do the easy one, and I'll let you guys try to tackle the pink rectangle over here. The area of any rectangle, including squares, let's just establish that, is equal to length times the width. Okay, so in this case, my length, let's call it this, and my width is this, right? You could have switched it, doesn't matter, right? But you're just multiplying the two sides together. If I multiply these together, I get length times the width. A is equal to x times the x. I use a dot to indicate multiplying. You understand, if I write an x for multiplying, it looks like 3 x's here. And x times x is what we call x squared, represented with the exponent 2. Okay, no more like terms, I'm done. See what you can do with this one. Okay, so just really quickly, I want to talk about 2 special scenarios, and that's when you have, it says there are 2 special cases of binomial products. Again, binomials are 2 terms that are added and subtracted together, and products is when you're multiplied, right? So when you're multiplying 2 binomials, for instance, this is actually 2 binomials multiplied together. Okay, same with this. These are 2 binomials multiplied together. Which do not require the use of distributive property or FOIL to simplify. So, like for instance, if you wanted to do this first one over here, what really happens is you have x minus 2 squared, which is the same as x minus 2 times itself. So you just write it out, okay? Same with this. Take the time to write it out. Then you go ahead and tackle it. Do FOIL. We're opening up the brackets now. We're going to multiply x times x, get x squared. We're going to multiply the x times the negative 2 in the end. These are the outsides, right? And you get negative 2x. You always write the number first, the sign, the number, and then the variable. Then you have to multiply the insides. Negative 2 times x is also negative 2x. And then negative 2 times negative 2 is positive 4. Looking at it, look for like terms. You got it right there, right? They always happen in the middle if you do FOIL. And here you got x squared. Suddenly I switched to blue, purple. Here we go, x squared. Negative 2x minus 2x is negative 4x, and you still have the positive 4. You got no more like terms because an x squared is not the same as an x term, okay? And we're done. Okay. Over here with the next one, what happens? Same general idea, but you're going to multiply with FOIL again. 4x times 4x is 16x squared. Okay. What about 4x times 3? That's 12x. 3 times 4x is also 12x, and 3 times 3 is positive 9. Okay, these are all positives multiplied together, so all my signs are positive as well. I end up with 16x squared plus 24x plus 9. And how was I able to get the 24? I noticed that these are like terms. Okay. So, in general, if you have a binomial that's being squared, all you need to do is write the first term and write a square on it. Okay, see that A? Just write it right there. Okay, goes right there, write a square on it. Then you write 2 times whatever your A is, times whatever your B is, and then you write plus B squared. You can follow this formula, and it's like a nice, like, quick way to get around things. So let me demonstrate it with that x minus 2 squared. I'll do it in purple here. If I did this little trick, okay, oh, and you take this sign and you write it here. Okay, this has to stay as blue, as adding. Okay, so watch me do it here. I take the x, right there, and I'm going to write it right here. Boom. And I got to write the square, so right there. Okay, A. What about the plus? No, it's a subtract, right? So just like we did over here with the green, I'm going to write that subtract right here. Okay. Next up is we have to write 2 because it says write 2. Okay, that's a part of the formula. And then whatever a is, so 2 times whatever a is, a happens in our case to be x. Okay, so 2 times x, and whatever b is. Okay, what's b? B in our case is a 2. Okay, those get written here and here. There's no squaring that needs to happen. Then we also have to write plus whatever b is, which is 2, and we have to write the squaring on it there. Okay, so watch me try to simplify this. X squared is simply x squared. Negative 2 times x times 2 is negative 4x. And over here, plus 2 squared, which happens to be 2 times 2, or 4. And I want you to notice that I got the same answer as this. You see that? They're both the same answers. So this is actually a handy little trick to be able to get through and maybe even check your work, or sometimes when you're in this form to jump back into this form. Like there's a use for this, but for a lot of students who don't necessarily want to remember this, you actually can just remember to write out the binomial squared as 2 binomials, and then just do all the work here and just multiply it out. Okay, and you'll still get the same answer. Okay, talking about difference of squares, these look like this. X plus 3 times x minus 3, you get x times x, which is x squared. You get x times negative 3, which is negative 3x. You get positive 3 times x, which is positive 3x. And you get positive 3 times negative 3, which is negative 9, right? Positive times negative is negative, 3 times 3 is 9. Looking at it right now, look at my two like terms in the middle. Negative 3x plus 3x, that's 0. Okay, not 0x, it's just 0, right? Or you could write 0x, 0 times x is 0. And all you have left is really x squared and the negative 9. Okay, so the moral of what I'm trying to say here is when I give you a question where the two binomials are the same, except there's an adding on one and subtracting on the other, but the numbers for a and b values here are the same, then you're going to end up with just 2 terms at the end. And they're both squares. You see that? Like x times x is x squared. 3 times 3 is 9, right? 9 is 3 squared. Okay, let's continue on over here. This should be, first, a difference of squares, right? And if you work it out, you're going to get 16x squared minus 8x plus 8x minus 4. Minus 8x plus 8x cancel out, and all you're left with is 16x squared minus 4. Right? Use the blue, highlight final answers. Okay, so in general, that's what you do with two binomials that are separated with just opposite signs there. All right, so students, some of these could be the first case, like we talked about, or they are the same binomial squared, right? Or they could be very similar binomials, but they have different signs here, so you have a difference of squares, okay? So they're either case 1 here, where you're squaring a binomial, or difference of squares. All right? You just have to know what you're working with. If you see a square on it, you write it out twice, like numbers 1 and 4. You're going to have to write them out twice. And numbers 2 and 3, they look like difference of squares, so you're just going to follow the steps and work it through. For practice, I want everybody to work through what would be page, I think, 3 to 7. Okay, so what that means is you're going to tackle these questions here. Okay, and really just, or 3 to 5, and really just drill and kill this. Get that practice in where you're working through these questions, going over each one, trying to see what you know, trying to see what you can get here, and do all the work, right? It goes all the way through to here, 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 and down to here. Okay. That's what I'm assigning for everybody to do. Let's spend a good hour trying to finish the stuff and do it. And we'll spend tomorrow taking up any questions. Ooh, please fix this. This should be a squaring. Okay. This should say squared. Fix that. All right. Hope you guys have a great day. Spend some time working on some math. Take it easy and shovel some snow and take good care of yourselves. I'll see you guys tomorrow morning. Bye.